you want to check out some really cool experiments, I've got them all here ready and waiting to show. It's about to begin.
What do you want?
We've got a lot of people down here. Welcome everyone to the first day of the day, the chemistry demonstration. My name is Malcolm, and now I'm one of the experts here at the Science Museum as we guide you through the demonstration this morning. Now, we're going to have lots of fun, lots of cool experiments we're going to show you. I am going to be asking very important things at various points during the demonstration, so please make sure you follow the instructions I'm giving you. Is that cool?
Yeah.
Yeah? Okay. Luckily enough, you don't have to have any instructions right now, apart from having fun with this. Really cool experiment. I'm going to make bubbles. I say I'm going to make bubbles. This machine's going to make bubbles. There we go. Takes its time. But every single one of these bubbles is one particular, come on bubbles, shape. So what's the shape of these bubbles? They're very circular, but this is a 3D shape. So a sphere, that's right, these are like 3D circles, they're called spheres. You've probably seen spheres at home. So can you name me any spheres? Lots of various different things that you might have at home that are spherical in shape. But I'll also very quickly stop this in a second. Because the bubbles that we have just blown out, they contain stuff that we breathe in. That's all around us. So what do we breathe in all the time? Oxygen, what was it we said? Air. Exactly. Air is all around us, and that's what we breathe in. Oxygen is part of the air. There's lots of other gases as well. But yeah, we breathe in air. But what I'm going to do is put a different type of gas into a bubble. So actually we breathe out something called carbon dioxide. You know carbon dioxide? Show me carbon dioxide right now. Show me carbon dioxide right version. Something called dry ice. Now dry ice is really cool, but it's also very, very cold. So, temperature of dry ice is minus 78.5 degrees Celsius. That means it's way colder than your freezers at home. It's even colder than some part of the Antarctic as well. So very, very, very cold. But what I'm going to do, again, as I said, I'm going to put, well, kind of, this version kind of, not really, because we can't really put a solid stick into a bubble. That's not going to work. But what we can do is something really cool. I'll first of all show you what this looks like. Now, for me to even dare touch it, I have to wear these gloves, because I need to make sure I protect my hands from the very, very cold temperatures of the dry ice. But I'm going to show you the dry ice right now before we get to the really cool parts. To me, dry ice looks like miniature ice cubes. Dig out some. There we go. You see, that is the dry ice. Miniature ice cubes. But again, very, 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 very cold. Especially in comparison to normal ice. Also, this does something that ice doesn't do. So what happens when you heat up ice? What does it become? Water. Great. Water is a liquid. We say that the ice has melted. Exactly right. We say the ice is melted to become water. Then say for instance you stick that water in a kettle, you put the kettle on, what does it end up becoming at the end? Very end. A gas version, and that is, you said it, steam. That's right. It makes lots and lots of steam. And we say the water, or the kettle, has boiled. It does bubble, but we say the water of the kettle has boiled. This stuff doesn't do any of that. This stuff goes from a solid, skips being a liquid, and turns straight to a gas. Like this. So the gas. Pretty simple. But we say that is something called sublimation. So everyone say sublimation. 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 Yeah, that is the process of going on from a solid to a gas, never becoming a liquid, and I'm going to show you that right now. This is the cool part. So, I've got some warm water here. going to heat up our dryers and therefore make it into, turn it back into carbon dioxide gas. I'm going to also ask you guys to make sure you have your hand and arms by your side, not on the table, just to make sure you're extra nice and safe. Again, this stuff is very cold. So, get me some dry ice, stick it in, 3, 2, 1. It's subliming! It's turning back into carbon dioxide gas. Although I will say carbon dioxide gas, as we've proved already, you can't see it. So the white stuff you're seeing is not carbon dioxide, it's actually condensed water vapour. Condensed by how cold, careful your hands, careful. Condensed by how cold the dry ice is. But now, very quickly, I'm going to stick all this carbon dioxide and the condensed water vapour into some bubbles. First of all, choo-choo train.
Wow.
Very much a choo-choo train, my gosh. Next, we've got to follow here with some bubble mixture, and stick some and make some bubbles. I'll see how many I can get to do. Oh my gosh. Yes, carbon dioxide filled bubbles. Now, I will say, or ask you, which direction are these bubbles going? Which direction is the bubbles going? They're going down precisely right. And that's because carbon dioxide is actually heavier than the air around us. It wants to sink to the floor. We say more dense. Oh no, more dense than the air around us. So again, it sinks to the floor. Well, that's pretty cool, isn't it? Is it cold? No? Oh. See, I can maybe do a couple more. Oh, I'll get tired. Oh my gosh. Come on, arms, you can do one more. Oh my gosh, you're doing it. No more, I'm tired. Oh. Okay, careful your hands, But yeah, so pretty awesome stuff using dry ice to create all this bubbles for you guys. But I have a way to prove that carbon dioxide gas is heavier than the air around us. So, I need this box here. I need some more dry ice, but this time we're going to do something called dry ice dust, which is basically just crushed dry ice. But it's still just as cold as the normal dry ice, so I've got to be very careful. I'm going to ask you guys to get hands away, hands by your side. I'm going to grab, maybe some, hopefully, there we go, some more dry ice. Just remember, we use like carbon dioxide is heavier than the air around us, so we get some more dry ice in here. And then, we'll spread this out. There we go. And to help it sublime, I'm going to blow into it because my breath is hot enough. Okay, now it's time to prove carbon dioxide gas is heavier. Hopefully this will work, because I'm going to use this again. Let's see how this goes. So let's see if I can get a bubble into the box. Whoa! What's happened to the bubbles? They're floating precisely right. Well, that is because, yes, the carbon dioxide gas is heavier than the air inside the bubbles. So the bubbles, I like to think of them as boats floating on a sea of carbon dioxide, if I can get them in the box, that is. Oh, come on! There you go. So tricky to do this. It looks easy, but so tricky. It's like, why? Oh, tiny bubble. Oh. But yeah, I will also say we can use carbon dioxide gas for one other reason as well, apart from having fun with this. So has anyone heard of the combustion triangle before? Yeah. Fire, exactly. Also known as the fire triangle as well, exactly. So you need 3 ingredients to make fire. 3. Anyone knows what those ingredients are? Yes. Fuel, oxygen, not gas can be a fuel.
Good enough.
Not water, not oil is a fuel. Something to do with heat, exactly right. Heat, that's the last thing you need. Fuel, oxygen, heat. Well, if you have a fire, hopefully there's going to be no fires in the museum today, but if you were to have a fire in the museum, we can actually help get rid of that fire by using carbon dioxide gas, and I'm going to prove it to you. Okay, so, I've got here, I have them pre-prepared, yes, I've got them, a candle. Now, I'm going to light this candle using this lighter. This lighter has actually got 2 of the 3 ingredients already there to make the fire. It's got fuel, which is inside, and there's a sparkle at the top which creates heat. So, oh yeah, well, the other ingredient, oxygen, already in the air around us. So if we do this, we get a flame. Well, I'm going to light this candle up. Come on, candle. There we go. And then, put this underneath here for a second. Because we've got all 3 ingredients going on with our candle, heat, fuel, and oxygen. But when I stick this in the box, watch very carefully. 3, 2, 1. What's happened? It's gone out, precisely right. We say it has been extinguished. But that's because of the carbon dioxide in the bottom of the box. Or is it? Well, kind of it is and kind of it isn't. Part of it is because of carbon dioxide is getting rid of the oxygen. And the other reason is that the carbon dioxide, to say, is so cold it sucks heat away from the flame. So you can actually get rid of 2 of the 3 ingredients you need. And just the extra proof, here's the flame. They get anywhere near the box, it goes out. It doesn't have any oxygen in the box, and there's no heat. It's very, very cold. So very, very useful. Actually, in the corner over there, we've got some fire extinguishers which actually do use this idea. So one of the fire extinguishers uses carbon dioxide gas, or it's more like foam, I should say, which then gets rid of the oxygen, and the other one is water, which cools down the fire, and by cooling down the fire you get rid of the heat, and therefore no foam. So we've got exactly what we need in case there is, hopefully, there isn't, but in case there's a fire today in the museum, we know how exactly to put the flames out. Well, now we're going to move on to the very last, the coolest experiment in this demonstration, which involves something incredibly cold. Something that we call liquid nitrogen. Now, liquid nitrogen, you know how cold this is? Dry ice is 178.5 degrees Celsius. Well, liquid nitrogen is minus 196 degrees Celsius. It's almost minus 200 degrees Celsius. It's incredibly cold. But that does mean, for me to do this experiment, I'm going to need to ask everyone to take a step back away from the table. And I want to see no hands, no arms, no weight off the table, please. Because I want to freeze you completely to that. That'd be very, very bad. I've got to also wear my gloves again. I've also got to wear some goggles as well, to make sure that I'm safe. To give you guys a bit of extra protection, I've got some safety screens here. And what I'm going to do is freeze some stuff. So I have here. I have some gumworms to freeze. Find it. Where are you gumworms? Aha! Gumworms. Oh yeah. Am I going to eat them? No. Actually, what I'm going to do is use them to pretend that's my finger. And I repeat, pretend. I'm not actually going to stick my finger into liquid nitrogen. And you'll see the reason why in a second. The other thing I'm going to put in there, liquid nitrogen, is this balloon. Okay. So, we've got our thing we're going to freeze, there's rock and roll. But all we need to do is get the actual liquid nitrogen. So, quickly grab the liquid nitrogen here.
아니 엄마 옆에 할게.
It's in this container because again it's very, very cold. Remember, hands away from the table, please. Hands away from the table. I think you're freezing your hands. If I was to freeze your hands like this, you'd get frostbite. Your fingers would go black. The gumworms are flexy, bendy, stretchy, and very heavy. But once you stick this into liquid nitrogen, things begin to change pretty quickly. It only takes about 8 seconds. So again, flexible stretching. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Actually frozen solid. Actually, it's so cold it becomes very brittle and can break. That's supposed to be more than I expected. Try this, try this. One more time. I'm going to do this one. With the blue, I'll do the 3 separately, don't worry. But yeah, then don't worry, I must have taken once again. If it was my finger, 1, 2, 3, 4, 5, 6, 7, 8. My finger would actually go flat, would become actually really solid, and would also break off like this, don't worry. Which would not be good. Just lost my finger instantly. So not good. That's why I'm not going to stick my finger in the liquid nitrogen. But lastly, the balloon. What do you think? Oh, sorry. What do you think first of all is in the balloon? What gas? Air. Yes, that's right. Oxygen is part of it. Yeah, exactly right. But we're going to use air. This is full of air. Yeah. So once I stick it into the liquid nitrogen is cold enough to cool down the air. And actually, what we're going to see at the end, it's pretty awesome. Because when you condense something, it becomes a liquid. So what we're going to have here, hopefully, is liquid air. So it's pretty awesome. Okay, there we go, we're ready to go. So if you look at the bottom, I can shake it about, you get liquid sloshing around at the bottom of the room. That is liquid air. But the air around us is actually warm enough, hot enough, to re-evaporate the liquid air and turn it back into the gas form of air, and therefore the balloon re-inflates itself. All by itself. But yeah, all because we're evaporating the liquid air, turning it back into a gas. Pretty awesome, guys. The things you can do with liquid nitrogen. But ladies and boys and girls, that is the end of the demonstration. I hope you guys have enjoyed it. Please enjoy us. Give down so much more going on today. See you guys later. Thank you very much.